let's start the new section. In this section, we're going to talk about how to read graphs and introduce the rectangular coordinate system. So the first objective will be read the bar graph and the line graph. So let me just show you an example of the bar graph. Let's see. If we have this kind of bar graph. We have this graph and we have see this one. We have 4 separate bars. And for we also have our horizontal line. Horizontal line we have different years. So here it's the horizontal line represents different years. And for the vertical line, we list several values, and these values means the profit. So this thing is the profit. The vertical line means the profit. If we are interested in the profit for 2011, how can we find that value? So we only need to locate what is 2011 first. We find this part. This one is 2011, which means we're interested in this bar, right? We're interested in this bar. So we want to know the profit corresponding to 2011. First, we find we're interested in this bar 2011. Then we only need to find the height of this bar. We know the height of this bar corresponding to this value. Then this is the value we're interested in. This is the profit for 2011. So again, first we check the horizontal line to locate which year we are interested in. We find the 211. Then we check the height of the bar to find the value. Okay, so this is the basic rule for all bar graphs. So first we check the horizontal line for different year or for different categories. Find the one we are interested in. After we located the bar, then check the height of that bar. Then that value is what we want. Okay, so that's called bar graph. Another basic graph, we call it line graph. Line graph. For example, we have this kind of line graph. This time we have this line graph. So in this graph, we still listed some values in horizontal line. And we also have some values for the vertical line. For example, we have this one. The horizontal line is the time. And the vertical line is tell us the pause rate. Okay, so this graph show us the relationship between the smoking and the pulse rate. So this 0 minutes means at this point the cigarette is light. The cigarette is light. So this 5 means 5 minutes after a cigarette is lit. So if we want to know the pulse rate 15 minutes after a cigarette is lit, so we only need to find the 15 minutes in our horizontal line. Oh, sorry, I didn't finish this line graph. So for example, we have this. Something like that. So if we want to find the pulse rate after 15 minutes after a cigarette lit. So first we find 15 minutes in our horizontal line, right? This horizontal line tells you the time. So 15 minutes. Then we try to find the point. The point will be here, right? The point is here. Then we try to find the vertical value for this point. Find the vertical value for this point. Then we realize it's just about a little bit above the 90, right? If this is 80, this is 100. In the middle will be 90, so this one will be about 93, 94. 93 or 94, something like that. So we can also use a ordered pair. So the first value we write 15. Then the second value we use something like 93. We can also use an ordered pair of numbers to represent this point. So first, we check the horizontal line. Find we are interested in 15 minutes after. So we find 15. Then try to find the corresponding point in the whole line. Then we try to find the vertical values for this point. Then that will be 93 in this case. After that, we can use an ordered pair of number 15, 93 to represent this point. So this is for the line graph. Okay. So next objective, we will talk about plotting ordered pair of numbers. So here we just introduce the rectangular coordinate system. We all know in the rectangular coordinate system we have x-axis, right? We also have y-axis. So the horizontal line we call it x-axis, and the vertical line we call it y-axis. And we know they cross at the one point. It's called origin. Right? We also have 4 different quadrants. So it's 1, 2, 3, and 4 quadrant 1, quadrant 2, quadrant 3, quadrant 4. So any paired numbers, any ordered pair of numbers can be expressed by a dot, by a point in this system, right? Let's check some example. So in a system, in a coordinate system, we want to plot, for example, we have a coordinate. So we try to find the 5, 3. So the first value, so 1, 2, 3, 4, 5, 6, 7, so negative 2, negative 3, negative 4. So negative 4, negative 5, negative 6, and here is the origin 0, and 1, 2, 3, 4, 5, and negative 1, negative 2, negative 3, negative 4, negative 5. So first we want to find what's the point A, right? 5, 3. So the first value here corresponding to the x-axis. So we want to find, it is just around here, 5, right? So we can have, it should be in this line. And then we try to find the second value, it's 3. So it will be like this one. So we can find 5, 3 will be this. The first value is the value in the x-axis. The second value, 3, corresponding to the value of y-axis. So first 5, then 3. This is how we find the point A. Let's check point B. The first value is negative 2, so it will be here, right? Negative 2. And the next value is negative 4, so it will be here. Negative 4. So negative 2, negative 4. It will be this one. Negative 2, negative 4. Okay, negative 2, negative 4 will be this point. So how about point C? Negative 5, 0. So we know the first number corresponding to the x-axis. So it's negative 5. And the second value is just 0. So we know this point is right on the x-axis. So it's here. So this point is negative 0. Because the value for y-axis is 0. So this point is right on the x-axis. And the last one, point D. We have 0 for the x. So which means the point will locate it right in the y-axis. And we only need to find what's -5.5. So here is -5, here is -6. So -5/2 will be like this one. So this will be 0, because 0 for x, right? -5.5. So from this value, we know the point is just on the y-axis. So this is for the objective B. We know each pair of ordered number can be expressed in this rectangular coordinate system. So let's check next one, objective C. This one is talking about how to create the scatter plot, scatter diagrams. For example, we have this table. We want to use the scatter diagram to express the table. So we have 2007, 2008, 2009. So this column stands for different years, and this one is the net sales for PetSmart, and we have different values. (6.1), 6.8, 6. So for example, we want to use the scatter diagram to express all the values in this table. What should we do? So first, we still need to list the horizontal line. And the horizontal line just tells us the different years. Okay, and we use the vertical line to represent the net sales. So we have 7. So it's 1, 2, 3, 4, 5, 6, 7. Then we try to check the first one. The first one, 2007, we have 4.7. So 2007 will be right here. And we want to find the 4.7. It's just right this way. Then we check the second value, second paired values. It will be 2008, 5.1. So 2008 and 5.1. So here is 5. So it's just a little bit higher than 5. It will be 5. Then we check 2009, 5.3. So it's a little bit higher than 5.1. 5.3. Then 5.7 for this one. And 6.1 for 2011, it will be this. And 6.8 and 6.9. So this is how we draw the scatter diagram. We just listed different points. Okay, we just listed different points. So this is called the scatter diagram. We can use this scatter diagram to represent the values in this table. Right? We use different points. So next objective will be the completing ordered pair solution. So let's check this one. So for example, we have this equation. Okay, and we have several paired number, but they are not complete order, not complete pair, right? We just have one value, one number in this paired number. So we should complete the pair by finding the missing value, right? So for example, the first we have 0 something. So we need to find what is the second value. And we know in each pair, the first value is just for x. The second value is the value for y. So here, for part A, how can we find the second value here? We just use this first value, 0, to replace x. So we know the first value is x. So we use this 0 to replace x. Then we have 3 times 0 will be 0. We get y is equal to 12. So we know the first, we solve this one. And now we have completed the pair. We know 0, 12. For the second one, we have to find what's the first value, but we already have the second value. And we know this 6 is just for y because it's the second value in this pair, right? So this time we're gonna replace y with 6. So we copy 3x, but this time we're gonna replace y with 6. Then copy the remaining part. After that, we know 3x is just equal 6. X is equal 2. So we also complete this pair. The first value is x. So it's 2, 6. Similarly, for part C, we need to find what's the second value. That is, we need to find what's the y value. And we already know the x value. So we use -1 to replace x, because -1 is the x value. And we copy the remaining part, plus y equals 12. So we want to solve for y, right? So we will get y is equal to 15. So we complete this pair, -1, 15. So this is how we complete each pair. If we know the first value, which means we know the x value, then we replace x with that value. Then solve for y. If we know the second value, which means we know the y value, so we use that value to replace y, then solve for x. So that's the objective. Okay, we check another kind of example. This time we want to complete the table of paired values. We want to complete the table. This time we list several paired values in a table. For example, first we have this equation, y is equal to 3x, and we also list the table we have. So first, we know the first column is for x, and we have 3 points. So let's check how can we complete the table. It's just the same thing for the it's almost the same thing like the previous example. This time we just use the table to list the different pair. So let's check for A, part A, we have x value, right? But we want to find the y value. So we just use this x value to replace x. So for the equation will be like y is equal to 3x. So this time we use -1 to replace x. We will get the y value is -3. So for part A, we know it's -3 for y. Then we check part B. This time we do not know the x value, but we know the y value. So we use 0 to replace y. Okay, this 0 is for y, so the equation will be like 0. So 0 replaces y, 3x. Then we solve for x. We know x is equal to 0. So we write 0 here. Similarly, for part C, this time we still do not know the x value, but we know the y value. So we use -9 to replace y. And copy the remaining part. So we solve for x, we get x is equal to -3. So we write -3 in this column. X value means x value for this point. So this is how we finish this table. We can try another one. We can try to do another example. So this time we have different equation. And we list the table. So we know the first column x, second column y, and the first point, let's see if -2, b 0, 0. Then we will use this equation, and the values we have to complete the whole table. How can we do it? Part A. Which value we have? We have x. So we copy down the equation, but use -2 to replace x. So for this one, we will get y is equal to -6, right? Because half times -2 will get -1. -1 minus -5 will get -6. So similarly, part B, we still have x value. So we can write down y is equal to, this time, x is equal to 0. So use 0 to replace x. The remaining part is the same. And this time we will get y is equal to -5. So write -5 here. And for part C, this time we have the y value. So we use this 0 to replace y. We copy down 0 for y. And this time we do not know x, so we need to solve for x. So from this equation, we know we have just like 5 equals half x. So x is equal to 10. So this blank should be 10. After that, we finish the table. Okay. So I guess that's for 3.1. Yeah, that's for 3.1.